Good morning, everybody. This is the fourth video in a series that I'm doing about two hots sharing a neutral, and I'm going to look at my sloppy drawing of the circuit diagrams. But before I do that, I'm going to give the same disclaimer I've given in the other three. I'm not an electrical engineer, and I'm not an electrician. I'm strictly a Google electrician, and I'm working on doing a basement refinish in my house. And I've just been trying to make sure that what I've got with my circuits is done properly, because I came across a circuit, I came across cabling that had a red, a black, a white, and a ground. And I wanted to make sure that the white is the neutral, that shared neutral was okay. So I've already gone through looking at the service panel, looking at the junction boxes, and showing the amp meter, the multimeter measuring the amps on ultimately what I measured was on the shared neutral, to make sure that we weren't having an additive current from the two circuits. So now I'm just going to look at the diagrams. If you're really not interested in the electrical engineering behind it, you can totally just skip this video, because you've already seen what you needed to see in the third video in the series, that when I had some current running through the furnace circuit and then I turned on the lights in the other circuit, the current through the shared neutral actually went down. It didn't go up. So it was the difference, not the sum. But for those who are curious, I'll just quickly go through the diagrams here without getting into Ohm's law and all that kind of stuff, to just show the basic diagram of why that happens with the circuits and why that is what we wanted to see. Okay, here's where I was scribbling my notes when I was trying to calculate the differences, and the numbers didn't work out exactly the way I wanted them to, but I did see that it ended up going down on the current ended up going down on the shared neutral. So the simplest diagram here of an alternating current is, here's your AC source. We can say this is the hot and this is the neutral. Once you've got the circuit wired and you've got a load on it, it doesn't really matter which one you call the hot and which one you call the neutral, because both of them have current running through them. That's the way a circuit works, is that current has to flow. So you have some type of load, some type of appliance, and I'm just calling that's the resistor right now. And what these show you is that the current actually ends up running in both directions. That's the whole nature of alternating current. So what you would think about initially is, since this is like what you would call the hot wire, you'd say, oh, the current is coming from the service panel through the circuit breaker, and it's running around the circuit in this direction. But this is an alternating current in the house. So what actually also ends up happening is the current can run this way. It doesn't matter which direction the current is running. The point is, for the appliance to work, it doesn't matter if it's a microwave, a stove, a refrigerator, a light, a laptop, anything. The only way this works is if current flows through the circuit. And the only way that current flows through the circuit is it starts from your AC source, it goes all the way through the appliance, and it's got to return through that same circuit. So what ends up happening is, if we are drawing, like the furnace draws about 8 amps when the fan is running. So if this is the furnace and the furnace is drawing 8 amps, there's 8 amps coming through here, but then there are 8 amps that need to be returned as well. So this is just a simple single circuit. And the key point that you need to know is that the wire that we typically call the neutral, when there's a load on the circuit, there's current flowing through the neutral. Okay? Otherwise, the circuit doesn't work. So here's a simplest circuit that we can draw here. The next and the final video, I'm going to show the situation that we have with the shared neutral. But the point to keep in mind, and this is alternating current. So the point to keep in mind is that when there's a load on the circuit, there's current flowing through the whole circuit. And it doesn't matter whether it's the neutral wire or it's the hot wire. It's the same amount of current running through both wires. The wires are of the same gauge, and so that circuit is rated at a particular current capacity. And in my situation, that was a 15 amp circuit. So there's up to 15 amps of current that can run through the circuit before the circuit breaker flips and just kills it so that the wires don't get overheated.